Hi viewers, welcome to Lama Solution. Today we are going to see about solar PV battery powered electric vehicle. This is a simulation model of solar PV battery powered electric vehicle. That electric vehicle consists of local load of the electrical vehicle is like a lamp load or a AC load, and we do have another load nothing but the BLDC motor drive. The BLDC motor drive used to drive that transmission to drive the electric vehicle. It consists of voltage source inverter, BLDC motor, and they have closed loop speed control. Here you are going to measure the actual speed of the BLDC motor, and it going to be compared with the drive cycle command, and going to be processed via PI controller. The PI controller will be generate the duty cycle, and it going to be processed via PWM generator. So the output of this PWM generator going to be compared with the gating pulse of the voltage source inverter based upon the hall sensor output of the BLDC motor, and finally the gating pulse and the pulse from the BLDC generator will be combined by using AND gate, and finally it going to be given to that the voltage source inverter to control the power of the BLDC motor or control the speed of the BLDC. And here we have 3 Newton meter load. This 3 Newton meter load always present in the system, because electric vehicle having a full load always, not to mention that we not to project that concept. Here we are making 3 Newton meter, and this BLDC motor drive going to be powered from the solar PV system and battery energy storage system. Here we are using 2000 watts PV panel, single panel having 250 watts, and nowadays you can see that there are a flexible PV panel available in the market. We can use that kind of PV panel in order to generate 2000 watts power from the source of sunlight. Here we use that 2000 watts PV panel, and here we consider 8 panel. The 8 panel will be connected in series. Here you can see that the voltage at the maximum power point for the each panel will be 30.7, and current at maximum power point is 8.15 amps. Single panel will supply maximum 250 watts. 8 panel in series, it can supply maximum of 2000 watts, and it going to be connected to the common DC bus. This is known as common DC bus. Here we are going to maintain the voltage at around 400 volt. Here we will get around 245 volt. Here we need 400. So we have used boost converter here, and this boost converter going to be controlled by means of a MPPT algorithm. Here why we are using MPPT algorithm means because the irradiation and temperature going to be vary time to time. If irradiation temperature going to be vary means the peak power of the people also will be vary. That can be seen in that PVA. Here we have the 25 degrees Celsius temperature in the PV cell, and here we are varying the irradiation right from 1800, 600, 400, and also you can see that the peak point of the PV panel for different irradiation condition going to be changed. We need to extract this peak point in order to get the maximum power from the PV array. For the purpose only we are using MPPT algorithms. Here we are using incremental conductance MPPT. It going to be received two inputs. One is PV voltage and current. The PV voltage and current going to be processed via the incremental conductance MPPT. This is a code for incremental conductance MPPT. You can check my YouTube channel. Already explain about incremental conductance MPPT. We will see the more elaborate detail on that YouTube video. Kindly check my YouTube channel over the incremental conductance MPPT. And the output of this incremental conductance MPPT nothing but duty cycle. Based upon voltage and current, incremental conductance MPPT will be adjusted duty cycle. So this duty cycle going to be processed via PWM generator. This PWM generator generate the pulse. This pulse will be control this IGBT of this boost converter in order to extract the maximum power as well as boost the voltage from 245 volt to 400 volt. And here we are using battery storage. The battery storage will be connected to the DC bus via this bidirectional converter, because battery can be act as a source as well as load. If excess power available in the PV, then it will be sent to the battery, and that means whatever power that means PV having excess power, that means more than load, then that excess power will be given to battery to charge. When PV is not have enough power to supply the load means during that time the battery will be supplied that a load of a electric vehicle. So for that we have this bidirectional converter, It will be work in both direction. It can take power from the solar PV or it can supply the power to the DC bus. This bidirectional converter going to be controlled by means of voltage control method. Here we are going to measure the DC bus voltage and it going to be compared with the reference voltage and it going to be processed by a PA controller and it going to be processed by a PWM generator. It will be generate the PWM impulse for this bidirectional converter not to maintain the DC bus voltage constant and also it will be change the direction of current flow according with the power balance in the system. And here we are measuring the PV voltage, current and power, and here measuring DC bus voltage and the electric vehicle input current and the input power, and here we are measuring a battery voltage, current and power, and here we are measuring the source of the battery, and here we are created that drive cycle, right, from 0 to 1.5 second. The speed of the BLDC motor will be increased from 0 to 2000 rpm. From 1.5 to 3.5, the speed of the BLDC motor maintained at 2000 rpm, constant speed operation. And from 3.5 to 5 second, the speed will be decreased from 2000 to 0. 0 to 1.5 second known as acceleration mode. 1.5 to 3.5 known as constant speed operation of the electric vehicle, and 3.5 to 5 seconds known as the deceleration operation of the electric. For that we created the reference speed command like that. Here you can measure the stator current and the EMF of the BLDC motor, and here you can measure the speed of the BLDC motor, and here you can measure the electromagnetic torque of the BLDC motor. And here we create that varying irradiation condition scenario. We have to investigate the system performance with the varying irradiation, because during driving the solar radiation will be vary. We have to project that detail. Here we varying the irradiation and you have to check the performances of the system like PV voltage, current, power, as well as battery charging, discharging, and we have to see the performance of the electric vehicle. For that we create this scenario. Now I'm going to simulate this model and you have to see the result of the solar PV powered electric vehicle results. Here you can see that PV power is initially the irradiation is 1000, after that comes to 800. Here you can see that so 1800, 500, 300 and 100 for every 1 second. Initially the PV power irradiation is 1000 watts per meter square. For 1000 watts per meter square, PV generating 2000 watts, and this here you can see the DC bus voltage maintained at 400, and this is all power of the electric vehicle, input power electric vehicles. There is excess power in the PV, that's why battery charging mode. And irradiation change to 800, it generated around only 1700 or 600 watts. During that time we need some excess power, that means we need power from the source. Because of that, battery going for a discharging. Here you can see that battery power is positive. Battery power is negative means charging mode. Battery power is positive means discharging mode. Here you can see that battery is discharging now because we need to supply power to the load. That's why battery supplying power now. That can be seen here. Initially it going for charging mode. After this once again we need to supply the load, that means electric vehicle power. So that's why battery is discharging. And here you can see that as per the speed command, speed will be rises from 0 to 2000 rpm and it maintain at 2000 rpm. So from 0 to 1.5 second known as acceleration mode, from 1.5 to 3.5 second known as a constant speed operation mode, and 3.5 to 5 second it going to deceleration mode. And here you can see that the electromagnetic torque of the machine is maintained is around the 3 Newton meter, and this is stator current and the EMF. The electromotive force going to be vary according to the speed of the DC motor. Now we can see that the PV power is very less. The battery is trying to supply the power to the load, not to make a power balance between source and the load. Here you can see that this is the power input power of the electric vehicle, because electric vehicle consists of BLDC motor as well as local lamp and some other loads, the input power of the electric vehicle. And here you can see that the speed variation, speed control of BLDC motor as per our reference speed command, it will be controlled very effectively. And also here you can see that this is a SOC charging discharging of the battery. So this is a result of solar PV powered electric vehicle. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye.